Okay, hello everyone. My name is Harshal. I work with InfraCloud, and I'll be giving you a brief overview of Ingress and how it works within a Kubernetes system. So, first thing that we want to do now is do a recap of services. So, services are a way to expose pods to other elements within the cluster or even entities outside of your cluster. So pods are running your application, but in order to expose them outside, we use services. And why do we use services? One of the main reasons is they provide a stable endpoint. So your pods can come and go, their IPs can keep on changing, but the endpoint that a service provides will remain stable. There are a couple of exceptions to this, and we'll talk about them as well. So we'll look at some various types of services that are there. So there is one service which is of type external name. So this is simply something that maps to an external entity. So you can have a service of type external name which says my internal name is mysql.local and it points to an RDS instance. So this way your configuration can always point to mysql.local, and then it can map to a local database in a dev environment, but RDS into a production environment. So this way you can just do a simple redirection of internal names to an external entity. The next service type is cluster IP. So this is a way of exposing your pods within the cluster only. It's not exposed outside of your cluster, and here you get an endpoint. So this endpoint will always match to all the pods which are described in the services selectors. So whichever pods are matching selectors described in the service, all those will be exposed via a single endpoint IP and a DNS name, and that DNS name can be used for talking to that service, and this is good for internal communication within the cluster. So an example of that would be a front end application sending something to a backend. So backend is exposed as a service, and backend pods can keep on changing, but the front end will only know the service DNS. The next service type is node port. So node port is a service type which is kind of a wrapper over cluster IP. So whenever you create a node port, it also internally creates a cluster IP service. So what node port does is it does everything that the cluster IP had done, but it also exposes that service to a predefined port on your worker nodes. So there is a port range of I think 30,000 to 32565 or some port numbers. So there is a port which can be specified by a user, or Kubernetes can choose that port by itself if it is not provided, and then on that port the service is exposed. So you can directly send request to node colon port and access the service. If your nodes have a public IP, even external applications can talk to your service, or you can also use a physical load balancer to access that service by adding all your nodes and ports as a member to a load balancer. So this is how a node port would work. The next type is a service type load balancer. So this is again a wrapper over node ports, which means when you create a load balancer type service, you internally are automatically creating a when you are creating a service type of load balancer, you are automatically creating a node port, which is also internally creating a cluster IP kind of a service. So what load balancer does is everything that node port did, and it will just add a load balancer on top of it and make your nodes and that node port as a member of that load balancer. So this is very cloud specific. So the clouds that support load balancer implementation, in that only for them a load balancer will be procured and services will be routed. Now load balancers are very easy because they make it easy to expose your services to the wider internet, but having one load balancer per public facing services can become very expensive. So this is where ingress controllers will help, and we'll talk a little bit more, and we'll dig more into its details. Exactly. So your internal DNS will have an entry which says mysql.local points to mysql.something.rds.aws.com. Exactly. kubedns will do that redirection for you. And then there is one more type called headless service. Now this is an exception to the overall scenario that we spoke about. So services in general create an endpoint, but in this case a headless service does not create an endpoint. So what headless service merely does is it just returns a list of pods. So you will have a DNS name, and whenever you query that DNS name, instead of getting one record of the endpoint IP, you will get actually a list of all the pods that match your selector criteria, and your application has to then handle the logic of working with those list of IPs and how you want to handle them. You're just getting a list. So
they directly forward to the pod. So they'll be service dash 0, service dash 1.
No. When you do NS lookup on that headless service, you will get a list of all the pods as an array, and now you can choose how you want to work with that array.
So, but it will be some sort of an FQDN, right? Some fully qualified domain name.
Yes, the headless service name itself will be FQDN, but that name would not resolve to a single IP.
So like an RR,
right? It's not even an RR. It basically just gives you a list. Exactly. It just returns a list of pod IPs. So if you were to create a headless service, and probably I'll just show you that in a demo also. So if you were to create a headless service for a front end application, so your front end application, let's say, has 3 pods, pod A, B and C. 3 of them have 3 different IPs. If you create a regular service, these 3 IPs would be fronted by an endpoint, and that endpoint would actually keep on routing to these 3, right? But in case of a headless service, when you query that front end name, you do an NS lookup on that front end name, it would actually return the IP of 1, 2 and 3.
This is for if I want to do some sticky section.
Yeah, there are some applications that could need a list of all the members every time a request is sent. So one of the examples is MongoDB pods. If they want to know which all members I'm having, so they can always talk to a headless service, get a list of all their current members. So now we'll dig into Ingress. So when we talk about Ingress, there are a few parts to it. The parts are Ingress resource. So Ingress resource is nothing but a set of rules. A set of rules which tells how to route something coming from outside to an internal service. So here what I'm doing is I'm creating a Ingress resource, okay, and I'm specifying rules. So here I'm saying any request that comes with a host header called demo.infracloud.space should be routed to this internal service. So this is a routing rule that is there in an Ingress resource. Okay. Next thing that we have is an Ingress controller. So now Ingress controller is a pod or a deployment which keeps on running within your cluster. It will keep on checking the API server for the Ingress resource, and the moment it sees an Ingress resource, it understands those rules that I mentioned and configures an internal reverse proxy to satisfy these rules. Okay, so I will look at an example and a flow diagram and everything as well. There are a few different vendors or distributions of an Ingress controller. So Nginx is one of the most famous ones. There is Traffic, which is also pretty commonly used. HA proxy is very recently released, and Envoy is something that is used with Istio. So these are some common Ingress controllers. Today we will be looking at Nginx. So with Ingress you can do 2 kinds of routing. You can do a name-based routing or you can do a path-based routing. So name-based routing is when you send requests to internal services based on the host name that is coming to your Ingress to your Ingress service. So for example, demo.infracloud.space would resolve to this service. You could have shoppingcart.something.com to a shopping cart service, shipping.something.com to a different, and so on.
Virtual host.
Sorry?
Virtual host.
To a virtual host, yeah. And then there is also path-based routing where you have a single host header, and then based on path you are routing your request to different services. So /prod would take you to a production service and /canary will take you to a canary service. So these are two different mechanisms with which you can do routing via Ingress resources. And there's one more thing in the Ingress system which is called default backend. So default backend is a kind of a catch-all scenario where anything that cannot be handled by the Ingress controller will be sent to a default backend, so that any request comes and if there are no rules to handle it, where do you send it? You send it to the default backend, and this is kind of part of the Ingress controller specification that every Ingress controller would have to implement. So we'll look at a flow diagram real quick. So let's say this black box is the Kubernetes cluster that we are having, and then we have an application which is deployed inside a deployment, and there is service of type cluster IP. Okay, this is internal to the cluster, and we want to expose that service outside. Yeah. So what we will do, we'll first create a Ingress controller and its corresponding Ingress service, which is of type load balancer. So what happens is we create a deployment for the Ingress controller, and we create a service which is of type load balancer and which will route requests to the Ingress controller. Okay. So this is a load balancer for the Ingress. So requests will come from here and go across. So we'll look at it further. So since we want to expose our application, what we do is we write an Ingress resource. Okay. The moment we create an Ingress resource, there is the Ingress controller which is watching for any new resource creation. So the moment it watches and finds an Ingress resource, it actually reads the rules and updates its configuration. Okay. And the moment it updates its configuration, it is ready to serve requests. So now there is a request that comes in. So there is a request that has arrived to the load balancer. Okay, that request straight away gets forwarded to the service, to the internal service, and from there on it gets into one of the pods. So this pod has the configuration which for the rules of the Ingress controller, right? So there it will do matching of the rules, and then once the rules are satisfied, it would actually route it to the internal service, and then the internal service will route it to your pods, and the service will get served outside. So we'll do a quick demo on this also. So for now I have a cluster with only system components running inside. So what I will do is I'll first create an Ingress controller on my cluster. So I'm creating a bunch of stuff over here. I'm creating Ingress controller in its own namespace. Then I'm deploying the default HTTP backend. Okay. Okay, sure. Better?
Yeah.
because now my kubectl probably commands might not show things. So, but I'll still. Okay, so deployment is service for the HTTP backend. Then there are a few config maps that are created. This is where all the routing rules are stored. And then there are service account and cluster roles to configure role-based access control for the Ingress controller. So the Ingress controller gets access to watch the API server for Ingress resources and so on. So this is all the RBAC setup. And then this is the deployment for the Ingress controller itself, and a service to expose the Ingress controller outside. And finally what we get is this ELB on AWS. So this is a load balancer which will create my which will actually be which will front my Ingress controllers. So through this ELB I can expose a lot of different services and applications. So next thing I'll do is I'll deploy a demo app, and we'll look at the routing rules, etc. So we'll look at what the demo app creates. Okay, so the demo app is creating. Let's look at it from the bottom up. So we'll have the deployment services and then the Ingress controllers. So we have a deployment. Deployment is called demo go app canary. So it's canary release of a small application, has some image with label canary.2, and then I have the same app deployed as demo go production and has a different image, tag called master. I am exposing these two applications via two different services. So I have a service called canary which has selector called demo go app canary, which would match here. I have another similar service for production. So these are both internal services of type cluster IP, and then I will create Ingress resources. So there's this Ingress resource which does path based routing. So for any host with this name and path/prod, the request would get routed to the production service. And similarly, for any request with this host header and this path, it will get routed to the canary service. Similarly, I have the host name based routing also. So this Ingress resource is only for routing things to my production service. So any request coming to this URL should directly get routed to my production service. So these are all the rules that I have created. So I have all my pods running. I have everything running here. So one second. So yeah, my demo go app SVC, the production services of type cluster IP. My canary is also of type cluster IP, and there is this load balancer which I have, right? So now I will do a DNS mapping of the load balancer with the host names which were specified in the Ingress rules. Okay. Let's demo. So I'll go to my hosted zone, which is infracloud.space, and I will just add a record set, which will be an alias to the load balancer. So I'll just is this is readable, or you want me to increase font a little bit? Huh? Okay. So it should load the ELB name in a few seconds. This is my ELB, so I can just paste it in. So I have created this record set, alias record, which is demo.infracloud.space, which will point to my load balancer that got created. Similarly, I'll create one more record set. This one is called Ingress test. And this is the load balancer. So now I have tied down the DNS name to load balancer to Ingress controller, and then to internal service. So all that chain is completed. So we can just when you do demo.infracloud.space, you get the demo app which shows which pod served this request. So this pod ends with DT54N. So this one. So this was a pod that served the demo request. Similarly, we can go to .prod. So /prod got served with the production service, and similarly canary got served with a different version of the same application. Similarly, we can host more applications, just route them through the same load balancer via multiple services. So, sorry? Okay, yeah, of course. So besides this, if I don't do anything, I have not specified any rules for ingress test.infracloud.space, right? So in this case, this should get handled by the default backend. So the moment I ran a sent a request to this one, it got routed to the default backend. So this is there. I just wanted to give a quick demo on the headless service also. Okay, so I'll just show you that one very quickly. So I have a guestbook app also. It's called guestbook.infracloud.space. So a regular service that I have for guestbook, it has a front end name, okay, and K describe, and if I describe this service, it will show me that this service is of type cluster IP, and it has this endpoint IP, right? And these are the endpoints available to the service. Still shows 2, should show 3 soon. Okay, there is one more in container creating. So the moment that gets created, you will have 3 IPs in the endpoint list. So now we have all the 3 IPs in the endpoint list, right? And all these 3 IPs will be served by this endpoint. This is the regular scenario. Now, if I were to create a headless service for this, you simply have to set cluster IP equal to none. The moment you set cluster IP to none, the service becomes headless. It doesn't get an endpoint for itself. And then if the DNS name is queried, you get a list of IPs. Okay, so we'll deploy this service and then we'll query this service from within the cluster. Okay. So we have a headless service which is created. Even though the type is cluster IP, the cluster IP is set to none. Okay. Look at headless service. So you can see it still points to the three pod IPs, but no endpoint IP here. Okay. Now what we'll do is we'll go inside a pod and we'll try to ping this service or do an NS lookup on this service. So just have to install DNS utils on this one to have NS lookup. So if I do NS lookup on the front end service, I just get one endpoint URL, one endpoint IP. So similarly, but when I do front end headless, it returns all the 3 pod IPs to me. So this was the difference that comes in with a headless service. So I'll just jump back to the presentation, and the demo, the source code for this is shared on a GitHub repo. I have mentioned it on the slide as well. So the prerequisite for this is AWS specific. So you'll need a Kubernetes cluster running on AWS, preferably via kops. And if you have a hosted zone, you can change your host names according to a hosted zone and anything that you want. Or if you don't have a hosted zone, you still want to play with it, you can edit your etc hosts on Windows or Linux and just point it to the load balancer IP and try it out.
So with the Ingress Controller that's running as a replica, that's actually on 2 different nodes. When you create the load balancer, does it actually route to both the instances?
No, it will route to any one of them. But the
both the instances will be in the target group of the load balancer, right?
right. So you have your Ingress pods running as a deployment, right? So whenever the request comes to the Ingress controller will route it to one of the Ingress pods.
No, I'm not talking about the pods.
Uh-huh.
So let's say I have the Ingress Controller running as like 2 replicas,
Mm-hmm.
and each of the replicas is on each of the nodes. Let's say I have 2 nodes.
Mm-hmm.
So when you create the load balancer, right? Like that load balancer should route the request to both the instances, right?
Right.
Does it do that by default?
I mean, you have a service
Yes.
in front of load balance,
Right.
to deployment, right?
No, I'm talking about the AWS load balancer.
Yeah, so AWS load balancer is talking to the Ingress controller's load balancer, which is internal to Kubernetes, and that is routing to the pods eventually.
So basically, AWS load balancer is just routing your request to the Ingress service. Ingress service then sends to Ingress pod.
The Ingress service, so the engine is Ingress thing, right? It can be running as multiple replicas of it.
Right.
So if it is on 2 different nodes, does it not? So what is the first node that goes down? Does it route to the second machine?
This is how any service within Kubernetes would work, right? So you are basically talking to a Kubernetes service, and if one of the pods goes down, what happens?
The node itself.
Yeah, if the node goes down, so the pod is not available anymore, right? So the endpoint controller for that service, the Ingress service, would have its own endpoint, and there would be an endpoint controller which will see that there is a node down, so one of my Ingress pods has gone away.
Okay,
So it will only
it's a load balancer to point the new node.
Yeah, so
Ex-
it's the
exactly.
It's the AWS will
It-
take care of it, right? So your load balancer is basically it connects to a node port.
Yeah, so I just want to confirm
So
whether
that
when you
node
create,
goes
so if you have like 5 nodes,
Mhm.
does the load balancer like or add all the 5 nodes in the beginning itself to the load
Yeah, you can
balancer?
configure your
So yeah, wherever your Ingress pods are running, all those will be added to your load balancer. And whenever someone dies or someone new joins in, there is an endpoint controller which is always checking for pods, right? So that an endpoint controller will make sure that your endpoints are always updated with the latest list of live pods.
Not force the nodes, right?
No, see,
No,
load balancer
there are
is
two
connecting
different
to-
things.
Load balancer
Yeah.
is connecting to, at the end of the day, forget about Ingress.
No, I'm talking not
Load
about the
balancer at the end
Kubernetes.
of the day is connecting to a node port.
No,
I
I'm
have
talking.
5 nodes.
Exactly.
And I have 5 Ingress controllers running as replicas on all nodes. At the end of the day, what happens when I hit the load balancer, which is still outside the Kubernetes now, it's
Yeah,
hit my AWS load balancer. What it will do is it will connect to the node port. Now, if one of the node goes down, the load balancer in the AWS world will know that this guy has gone down because it was registered. So
Right.
it will not route that request to a particular node. Right? It will go to the other node.
Yeah, I was actually talking about that since I wanted to know when you like the load balancer is itself created by the Kubernetes, right? Because it has a permission to create.
Yeah, but it is still managed by AWS, right? It's an AWS ELB. So ELB will keep on looking at its members, and if someone goes down, it's not available, it will not route requests to it.
No, so like my concern was when you like in like Kubernetes in like Ingress controller creates a load balancer, it attaches all the nodes available, right?
It would, yes, it will attach all the nodes because it's a node port after all. Like it's a service of type load balancer which will internally have a node port also.
So it's just abstracting the load balancing to the AWS stuff.
Right. Okay. So advantages of Ingress, you can use one load balancer for multiple services. So like we saw, I exposed 2-3 different services using the same load balancer. So that can help you save out on cost of load balancer if you have a lot of public facing services. You can do name based and path based routing very easily. So that is there. Ingress controllers can be used for SSL termination also. And worker nodes can still remain in private subnet. You don't have to expose their ports or something outside to get access to. So yeah, so that was the demo and session. So thank you very much for attending, and also thanks to Big Binary for hosting us. So that's it.